Hi everyone, let's solve today's LeetCode question. So the question's name is 29 minimum size subarray sum. Let's read the question. Given an array of positive integer norms and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, then return 0 instead. Okay, let's see what it means. Means minimal length of subarray whose sum is greater than or equal to target. So minimal length of a subarray whose sum is greater than or equal to target. Okay, so I can say that 2 3 4 5 6, right? This is 6, this is still not less, still not equal to or greater than target. 6 7 8. Okay, now this can be one subarray, right? So this can be one subarray, 2 3 1 2. And what about other? I also want to see the constraint. So target is I just wanted to see if norms can be negative, positive or not. So it says that target is each greater than 0, and norm start length is greater than 1, and norms I, it is from 1 to 10 to the power 4. Okay, so it means there will always be a positive number. The number it is not negative or it is not 0. Okay, got it. So 2 3 1 2, this is one subarray, possible subarray, right? And another possible subarray is, I think, from, so I just start from 2, let's start from 3 3 4 5 6 6 4 10. So this is another possible subarray, right? And another one 1 2 4 4 5 6 7. Okay, nice. So this is exactly equal to 7. It means that this is the 1 2 4. So this is the subarray that has a minimum length till now, right? Okay, and another one is 2 4 5 6 7 8 9. Okay, this is also one of the, and another one is 4 5 6 7. Oh wow, this is perfect. 4 3. So this is equal to 7. The sum of the subarray is equal to 7, and the minimum length is 2, right? So the answer is 2. Great. And for this question, the target should be 4, right? So the answer will be just 1 only, because there is just 1. Okay, and for this one, like, we can see that even if I add all the numbers, the sum will never be equal to 11. So that is why it is 0. Got it. Follow up. If you have figured the out the O of n solution, try coding another solution of which the time complexity is O of n log n. What? So there is also a solution with logarithmic time complexity. Okay, let me figure out O of n solution first, and then I'll try to figure out the solution. So what is O of n solution? How to come up with O of n solution? And then O of n solution, and then O of n log n. Okay, but O of n log n is even greater than O of n, right? Yeah. Okay, anyway, I will try to first code O of n solution, or first try to think about a brute force solution. So let's take this example, and suppose the target is equal to 7. Then how to come up with the array? So the approach that I took before was I would just start from all the elements, right? All the elements. But if I just start from all the element and keep on getting the sum, then our time complexity will be O of n square, right? Because I'm doing it for every each one of these. I usually start from 2, and then I will also start from 3. I will also start from 1. Is there a better solution? O of n solution. I want O of n solution. So there is O of 1 solution. I want O of 1 solution. Okay, so how can I do of one? So for of n, I just need to go through this array once. 2, 3, 4, 5. So it is all the elements in this array, they are all positive integer. Okay, they are all, this is an array of positive integers and a positive integer target. So how can I do this? I want a minimal length of subarray. Interesting question. Let me think. So this is 2, 3, 5, 6, 2 and 3, 4, 5, 6, 2, 5, 6, 7, 8. So I got 8 here. Two, 3, 4, 5, 6, 7, 8. I got 8 at this point. And 3, 4, 5, 6. Actually, you know, of and log n solution is even easier because I can just sort. Oh, I cannot even sort the array actually. Because if I sort the array, then it will be difficult for me to say, you know, okay, this is the sub array, because if I sort the array like this, then it will be, I cannot the concept of sub array is gone after I sort it, right? I just want the sub array. Sub array means the sub array means the smaller array within array that is contiguous, like 1 to 4 it's a sub array. Here see 1, 2 and 4, they are so far apart, so I cannot sort it. So if I cannot sort it, how to do it with of and solution? I mean, I need it for all the, so 2, 3, 4, 5, 6, 7, 8. So at this point I know that I'm not going forward, right? Oh, can I do one thing, like 2, 3, 1, 3, 2, then can I do, so when I reach at this point, I know that 2, 3, 1 and 2, I know that it is greater than 8, right? So what I can do is, I think I can just I can also run another point to say that, okay, this software has started from this one, and then, you know, if it is greater than 8, then I can just move this pointer, right? And then I can just delete this. The main concept is just keep on deleting the first element. So if I delete this one, the first element, then it will be 3, 4, 5, 6. It will be 6. It will be equal to 6. 3, 4, 5, 6. Now I will continue. So 6 plus 4, 10, right? So it means that this is greater than 7. So whenever I find something greater than 7, then I also need to update result minimum length. I'll also keep on updating. So minimum, it will be equal to method minimum of minimum length comma j minus I, right? So because here it is 0, 1 and 2, 3, 4, right? So 4 minus 1 is equal to 3. 0, 1, 2, 3, 4. So 4 minus 1 is equal to 3. So it means it should be j minus 1 plus 1. So this will be the length of the current subarray, right? So I will update this. So I will keep on, whenever I'll just call it running sum, whenever running sum is greater than or equal to target, I'll just update minimum length, and after that I will subtract. After that I will just remove the first element, first element from the running sum, first element of current subarray. I'll just remove the first element of current subarray. Okay, so running sum is its sum of current subarray. So this is what I was thinking. So running sum is sum of current subarray, and whenever I find that okay it is greater than target, then I will just delete that one and see if that one is, I'll just delete this, because if I delete the first number, then it will be it's like I'm starting from the next number, right? Okay, so yeah, it's like I'm starting from the next number, so I'll just delete the first element and then start from the next number. So yeah, and then keep on continuing like that. And yeah, so if whenever running sum is greater than or equal to target, do this. Otherwise I'll just add current to current subarray array and update running sum. Okay, so I will do this until I reach until I will do this until I until I reaches at the end. So if I see here, so I reaches at the end, and if I delete this, then 4 5 6 7 8 9, it is still less, so I will just move further. Now 4 5 6 7, it is equal now, right? So yeah, whenever running sum is greater than, do this until I reaches at end, and whenever running sum is greater, while, let's do this. Okay, I think I got O of n solution, so let's code it. And what about this condition? So if the sum is never equal to target, then the output should be 0, right? So what I can do is I can just say that the length of minimum length is 0 in the beginning, and if this condition is never fulfilled, then this will never be updated, right? Okay, so, and there should be running sum as well. Running sum is equal to 0, and while, what should I do? Do this until, so let I is equal to 0, and while I is less than norms.length, I will keep on while it's less than or equal to length, and running sum, so running sum will be equal to norms I, and if running sum is greater than or equal to target, I also need J actually. Yeah, while running sum is greater than or equal to target. So yeah, if running sum is greater than or equal to target, then I'll do something, but if it is not, then I need to increment I++, and J will be there only. Yeah, and if running sum is greater than or equal to target, then at that point it is greater than target, so I need to update min length is equal to math.minimum of min length comma j minus I plus 1, right? So this is one thing, and I also need to remove the first element, right? So removing first element means running sum is equal to running sum minus norms of j. So yeah, So this means that remove first element from current subarray, and then I do this, right? So if running sum is still greater than or equal to target, then I'll do that again. Oh, if it is equal to target, then should I do this? So suppose there is 3 and then 4 here, okay, and j is here, 3 4 5 6 7. So j comes here. Now this is equal. This is equal, so should I move I? Or since this is equal, like moving I, this will always be greater than target, I know that. So I think that there is no point of actually moving I, because I know that this will always be this. So I'll just move I and then move I again. Yeah, that's a good idea. Move j, move I as well. So what it will be like is, so the running sum will be 4 when I move j, and when I move I, then next running sum will be 4 5 6, right? At this point, yeah, good idea. J minus I plus 1, and at last return minimum length. Will this work? I just have a habit of submitting without I was saying, so I just have a habit of submitting without looking if it works. Should it be j minus I or I minus j actually? Oh, it is still not working. I want to cry. I minus j. So if it is here, then so 0 1 1 minus 0 plus 1, I minus j plus 1, minimum length is 0. This is how I am deleting, and j plus plus. Then if it is still greater than or equal to target, then I'm doing it again, and at last I'm incrementing plus plus. Why is it not working? Oh, case 3 has worked, obviously. So is my algorithm flawed or what? I think my algorithm should work, right? Because I want, so okay, let's concept check on my algorithm. What I am trying to do here is, I'll just look at all the subarrays, not all the subarray, because looking at all the subarray will take O of n square. So I will look, so here what I'm doing is, once I find that okay, this element is greater than or equal to target, so okay, so once I find that, I started here, once I find that okay, this element is greater than or equal to target, okay, suppose once I find that this element is greater than target, right? So it means that there is a possibility that there consists of another subarray within this subarray which might be equal to target. So that's why I just contract that subarray and see if there is another subarray within that subarray that is equal to target or even less. So I just keep on contracting until, so j and 3 4 5 6 7. Okay, I find it now. What? So I know that 3 and 4, they are equal, so instead of looking at 3 4 2, I should look at 4 2, right? So I'll just do j and then I as well. So if I am looking at this question, then first of all I will I is also at 0, j is also at 0, so I will move on. So 2 running sum will be first of all 2, and then 3 4 5 5 6 6 7 8, right? So this is my subarray that I am getting. The value is 8. So 1 2 3 4, my result will be equal to 4 at this point. Now if now I know that okay, this is greater than 8, right? So I'll try to contract it now. So since this is the subarray that I'm looking at, I'll try to see if this, what about this subarray? I'll check that. So here I'm only coming from start, right? What about this subarray? It is 3 4 5 6. The result is equal to 6. So I'll continue, and this is equal to 10. So now I will do 10 minus 3 is 7, right? So since this is equal to 7, so I will just continue j and continue I again. So this will be 4 5 6 7 8 9. Since this is greater than result, so I will just contract j. So 4 5 6 7, this is equal to 7. Now it will be equal to 0 1 2 3 4 5. So it will be equal to 5 minus 4 plus 1, that is 2. So the answer should have been 2. Why is it not working then? So I is equal to, I mean my algorithm is fine for this question. So yeah, after I find one subarray, then I am just contracting. After I find 1 2 4 3, then I'm just looking at 1 2, I mean just looking at 2 4 3, and then 4 3, okay. So minimum length is equal to 2, running sum is equal to 0, running sum is equal to running sum plus norms I What's wrong here? I don't get it. Let me zero, 1, 2. So first of all, there is 2, 2 at 0. So when I is equal to 0, then running sum is equal to 2. When I is equal to 1, then running sum is equal to 5. When I is equal to 3, 0, 1, 2, 3, then running sum is equal to 8, right? 3, 4, 5, 6, 7, 8. Now I deleted. Why should I? After 8 I deleted the first number, that is 2, and running sum is now ing. So j is here. Now running sum is, sorry, I always miss this one. Now running sum is at 6, and I will increment it again. I is at 4 and running sum is equal to 10. Now I delete this one, 3, and running sum is equal to 7. Now I delete it again. Oh, you know what's happening? Oh my god, how stupid is that? Math thought max value or something like that. How to get that math dot max value? JavaScript. It is number dot max value. Okay. Number dot max value. Because like I am just doing minimum length, right? So it will always be 0. Can say norms dot length, and if I know that min length is equal to norms dot length, then I will return 0, otherwise return min length. What if min length is equal to norms length? Oh, norms dot length. Oh, I cannot do that. Actually, what I wanted to do is, can I just say, so how will I know if it never, running sum never got to target? Or yeah, actually I could have done minimum norms dot length plus 1, because there will not be a subarray. That is a bad idea though. Okay, challenge completed. Let's create. Let me look at the solution. Approach sliding window. Okay, so the approach that I did was a sliding window. Yeah. result is equal to float. What is float? Okay, they also did number that infinity. Yesterday's problem was also sliding window. Yeah, I got running sum first and then previous running sum. Actually, I'm solving a sliding window problem without knowing that it is a sliding window. Anyway, thank you everyone who is watching. Bye.